AE. Isn't A equal AE? A concatenation E? Okay, so then I do have an E up there. So if this is the situation and I ask you the question, is E on the top of the stack? This is always true. Is E on the top of the stack? This is always true. But if I ask you the question, is A on top of the stack? This is true in this case. So it's like the function you did in data structures, look on the top of the stack. Here it's a little bit variant of what you did in 302. Okay. So this means if E is on the top of the stack, well, it's always. Replace E by A. This is, as we said, like pushing A. So if you see an A on the table, you push it on the stack, it says. Okay, what does it say? If you see C on the table, what is it doing on the stack?
Okay.
Replace nothing by nothing. He does not touch the stack, leave it alone. Replace E by E on the stack means do nothing to it. And what does this say? If you see B on the table, if you have A on the stack, which will be true if the top's real symbol, not the, is A. I mean B. A. So if you have A on top of the stack, right, replace it by E means pop. Now what's the real top of the stack? A. Yeah, you just popped it. All right, so here they gave you a PDA. Now, some of the states are final. Now, a PDA recognizes a language. What is the language recognized by a PDA? All the strings that will drive it to a final state. Okay. All strings for which there is a path that ends in a final state, having read the whole string and leaving the stack empty. All three conditions have to be satisfied. Then if there is such a path, you say the string is accepted, he is in the language. The string is in the language if there is a path through following transitions, if there is a sequence of transitions I can follow, to leave the stack empty after I read the whole string. And I should be sitting on a final state. So that's the language of the. Let's try to figure it here. What's the language accepted by this guy? Which strings will get you to an empty stack? Let's take like A squared. If this is on the table, okay, of course, always when we start this, we start at the start of the table. Okay, what will happen? I'm in Q1. Okay, I see an A on the table. I cannot follow this transition. Can I follow this transition? Well, you could. What's on top of the stack? Well, when you start, the stack is empty. So E is on top of the stack. So instead of Z0 special symbol, I use E. So this is true. So what does it say? Push A on the stack. Replace E by A. And every time you fall in transition, of course, you move down the table. You don't have the ability to stay there. Okay? Unless you have E, unless you don't use the table, which is an option. Okay? So I'm here. I'm still in Q1. Well, I got to follow this again. I cannot use this. Okay, A, push it. Do you have E on top of the stack? Sure, A, push A. So this one, you'll be pushing the A's on the stack conceptually. Okay? When you see a C, move over without touching the stack. So I just changed to this tape. And my tape is here. What's the current symbol now? B. Do you have A? Yes, I see a B on the tape. A is on top of the stack. Pop it. Replace A by E on the stack. So when will the stack be empty? If my number of B's match the number of A's here, when I'm done, see a B, pop. See a B if you have an A, pop. Okay, I'm here. Right? I finished reading the tape, the input. Okay? The stack is empty. I'm in Q2, which is final. So this string is accepted. Okay? How do you know you finished the string? You can imagine a blank symbol on the tape. The tape is initialized with a bunch of blanks. So it's a marker, right? You know, the end of line or the end of file. Okay. So this is a subset of the language. You did not prove this is the language yet. Okay? Maybe there are more strings that are accepted. I don't know yet. So let's take some cases. What if you had more A's? What will happen to this PDA? Will they be accepted? Why not? There will be some, the stack will not be empty, be left over. Okay. What if there were more B's? What will happen?
Cannot move.
We don't have a final string. We don't have a symbol to.
Yeah, two pop.
What will happen is after the 3 A's, with the 3 B's you will pop, the stack will be empty now.
So it cannot
But you will be sitting at a B on the tape. And the top of the stack will not be A. You will be in a final state. You will be in a final state. And there will be B on the tape, but the top of the stack will not have A. So you cannot apply this transition. So you will be stuck in the first extra B, the PDA will get stuck there. He cannot move. Because you did not give him a rule to tell him what to do if you see a B and the stack is empty. There is no rule, I'm stuck. So you say he hangs here. He got stuck here. He cannot process the rest of the string. So this string fails with more B's, right? Because he cannot read the whole string. He cannot process the whole string, even though the other two conditions are satisfied. You're here. You see a C on the tape, you can do this right away. Don't touch the stack over here. So what do you have? You read the whole string. C. Is the tape, is the stack empty? Sure, you never touched it. Okay. Are you in a final state? Yes, so C is accepted. So for N0, you get C. This is the language recognized by this PTA. So is this language context free? A language is context free again if it's recognized by a PDA. Yes, here is a PDA for it. Is this language regular? No, we can do the Pampinima.
Yes.
It's a variation of AN, BN. So here are all the possible regular languages in the world. Okay. Take the set of all the regular languages. Take the set of context-free languages for which there is a PDA. Is it true that if a language is regular, then it will also be context-free? Yes. Now, why is that true? Yeah, it's a proper subset. Again, it's not equal. If a language is regular, this means there is an FSA for it. Right? So is it also context-free? Yes, because every FSA is also a PDA. So if there is an FSA for the language, there is a PDA for the language. I can take any FSA and convert it to an equivalent PDA. How? I'll give you an FSA, right? It could be deterministic, not deterministic, I don't care. But let's say it's deterministic. If I can make the argument for the deterministic case, I'm done. Because if it was known, I can convert it. Okay? So I'll give you a deterministic FSA. Alphabet is A, B, C. Okay. it recognizes some language. B star A union B star. Whatever the language is. Okay, can I build a PDA that is the same as this? It recognizes the same language. Okay, to convert an FSA to a PDA, what do you need? What's missing? The stack. Okay, so the only difference in the notation is in every transition we have to tell it what to do to the stack. So what should this guy do to the stack? Do you need the stack? You don't need it. So basically stick a stack there but ignore it.
Yeah.
So I should put what? What do you, right. I can take every transition, put E, comma E, which basically he says just ignore the stack. Now you get a PDA. It's the same. So every FSA is a PDA by ignoring this stack. So if a language is regular, is it also context free? Sure, yes. Because there is an FSA, therefore there is a PDA, because every FSA is a PDA. Now the other way, if a language is context free, is it also regular? No, you just showed me this example. This is context free, but it's not regular. So this is a proper superset. There are some things not in regular. Right? Language, we know this is not context free also, right? A and B N. I would like to build a PDA now for this language. The only reason I had the C here on the tape is so I know when to switch to popping. Conceptually, in PDAs, every state is also has a semantic explanation. What's the name of this state? The pushing A's state. Well, while there, push A's, as long as you have them. A push, A push, A push. It's a while loop. The only purpose of the C was to know when to switch to the popping state. Push, push, push. You see a C, now it's time to pop. Right? Now, what if this was the language, though? I don't have a signal to know when to. So who can modify this to do this language? So this doesn't work anymore, right? So, so you say push, 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 push. A push, A push, A push. What should I put
C
here?
or B or
B.
probably
Yeah.
Okay, when you see a B, what should I do?
Epsilon equals the next state, E comma
A, comma E.
E comma E.
If you have an A pop, right? Okay, let's see if this fixes it. Is this language truly? Okay, let's take this string
N is 0.
AABB. Okay. Well, I'll do this pop twice. I mean this push twice. Okay. Then I'll be here. Then on the stack I have AA. Right? I can apply this once. I see B on the tape. Do I have A on the stack? Yeah, I have it. It's popping, so replaced by E. Then I'm here. Can I use this transition?
Yes.
Yeah, you see a B. Do you have A? Yeah, I have A. Pop it. I finish the string. The stack is empty. I'm in the final state. Yes, this will be accepted. No problem. So, how about AB? Sure, no problem. So for sure this is accepted.
Yes.
But now here I have an equal 0. So what's the language of the thing? Right?
Yeah.
But does it also do that? For n0, I must accept the empty string. Okay. So what if I have nothing on the tape? You know, I have the empty string, which means end of file right away. That's it. Okay. Not even end of line. End of file. Boom. That's it.
We cannot move the final state.
Well, what would happen? I'm here. Do I see A on the? I don't see.
No.
Unfortunately, I don't see an A on the tape. I cannot do that.
Right.
Do I see a B on the tape? I don't see a B on the tape, so I'll be stuck here.
Yeah.
So the PTA will say no good. So the language of this guy is not this, it's this. ANBN with N positive is context free because here is a PTA for it. Okay. Now my question though was this: can you build a PTA for this guy? So somehow I have to take care of the empty string. Do you follow?
Yeah.
Okay, this one doesn't. So who can modify it to take care of the empty string?
just one state.
Or you want to make this final?
Yeah, and then make that B transition also here.
What?
The same B transition.
Which, I don't know, this one?
That one. Yeah.
Do
Do
it
the
what?
same thing here. Like real.
You want to put the B transition
Yeah,
here?
yeah,
Copy it?
yeah. And remove.
We can
that.
try that and see what happens. Like that?
Yeah.
Well, okay, let's look at that. Okay, the empty string. Is he accepted? I'm here, the stack is empty. I don't need to use any of the tape. I read the whole string. Right? I'm at the end of file. So he's accepted. The empty string is accepted. But by just doing this. Okay. Now,
Yeah, this will work. If we have. This is.
now,
same
do
one.
we need this thing? Okay, it seems like we don't need it because our only problem was I was missing the empty string. So this fixed it. So I don't really need this. But suppose I inserted it. What have I done? You know, is the language still, so the language of this guy is this. No, I inserted that. Is the language still that? I don't know, let's examine it. Huh?
Yeah. The only condition
Well,
is.
everything I give you here, it will still be accepted.
Right.
Once you have a PDA that recognizes some language, you can put any arcs, transitions you want on it, on top of it, it will still recognize the same strings.
Right.
Because the string is accepted if there is at least one path. And if there was a path, there is, you did not delete it any, right?
Right.
Still there is a path. The only worry will be, can I recognize strings that I was not able to? You know, did I actually increase the language? Now I have a superset. So let's see. Can you think of a string that will be recognized here that was not before, if I have this arc?
Yeah, A, B, B, A.
Let's see, A, B, B, A. Let's take A, B, B, A. It's not in the language, but is he recognized by this? Let's see. You're here. You see A on the tape. You can push it. Right? You're here. You see B on the tape. And you do have an A on the stack. You can pop it. So, actually, A, B, B, A will not be.
No,
but-
yeah, A, B, A, B.
A, B, A, B.
A, B, yeah.
So you see an A, you push it. You're here. You see a B, you do have an A. You pop it. You see an A, you push it. You see a B, you pop it. You're in a final state, the stack is empty. You finish the whole string. So this guy is also accepted. So you just increase the language by the language is not A and B anymore. It's it's what?
A, B star. A, B star.
A, B. Yeah, but the language is not that.
Yeah.
That one too.
Right.
You can still do that.
Yeah.
So it's that union what you said. Right. You still are doing the things you used to do, but you do more strings now. And is that all? I don't know. You can also have even more than this. For example, I can give you, the language is even bigger than this actually.
Yeah.
Let's say I give you this. I can do that.
Yeah. Yeah.
As long as every time you have a B before it, you have more, you know,
Yeah, more.
you have enough on the stack.
Right.
Before the first B, I have 2 A's. I have more A's. Before the second B, I have 3 A's. If the position of B is less than the number of A's before it, you can always get the string as being accepted because you will have something left on the stack. Before the third B, I have 3 A's. So if it's the position of B is less or equal the number of A's before it. If that formula is true, the string is accepted. So actually the language is not that either. It's difficult to express it. The language is any string in A, B star such that for every B, the position of B in the string is less or equal the number of A's before it. Okay. So this is satisfied, right? The position of B is 3.
Yeah.
Bigger or equal or less or equal? The position of B.
Is greater than the question.
Oh, this is
Number
not
of-
the position of B.
number of-
The position of B in the B string. This is the first B, the second B, the third B.
Right.
This is the first B. It's less or equal to.
The
Yeah.
number of-
This is the second B. It's less or equal to. Yeah. So this will be satisfied. Right. The one you said, that's a special case. A, B, A, B, A, B. Right. The first B, less or equal 1A before it. The second B, less or equal 2 A's before it, right? The third B, less or equal 3 A's before it, right? Okay, so you got to be careful. Okay, so what's the language of this? A n, B n, n bigger or equal 0. Now let me do something here. So you use the first B to deterministically, you use it as a marker, right? To switch the position, the state, right? Now let me do this. This is a PDA, right? Remember in non-deterministic automata, I could do stuff like, oh, if you're here, if you see E on the tape, this means don't use the tape. You could have the empty label on an arc in NFSAs. Whenever you want, don't use it. You can switch states if it's necessary. Same thing here. What does that say? If you're in this state, if you have E on the stack, this means it doesn't matter what's on the top of the stack, whatever it is. Leave the touch alone, the stack alone, and just switch. This is a non-deterministic switch. You can apply this rule anytime you want.
Right.
And there is no condition. I just go if I want to. Right. What is the language recognized by this guy?
And
What? Right, it's the same language.
It's the same.
Right, AN, PN. It's the same language. So how come? Okay, let's try some strings. The empty string, will he be accepted? I'm here, well now is the time to do this transition. Right, just move. I'm in a final state. Is the stack empty? Yeah, I don't touch it. Do you finish reading the empty string? Sure. He's good. So you just make the move to the final state, he's good. Okay, let's take AABB. Is he recognized? Do I see an A? Yes, push it. Okay. Now I'm here. I see an A, push it, I apply this transition. I'm here. Okay, now, I can do this move at any time. Suppose I choose to do it now. Right? I make this move. Now I'm in Q2. Can I apply this rule? No, because I'm not looking at the B. So I'm stuck. The PDA will be stuck here. He cannot finish processing the string. And the stack is not empty. He is in a final state, but what good is this? Will I say this is not accepted? No, we said the string is accepted if there is at least one path that satisfies those three conditions. You just chose the wrong path here, right? There is still a chance there is one. You just made this move at the wrong time. So what's the right path? I see an A, I push it. Don't do this yet. That would be wrong. Do the push one more time. I still see an A, you push it. Okay? Now do the move. At this point you have no option. You cannot, there's nothing with B here. Now do the move. And now pop two eyes. He's recognized. Okay? This is a non-deterministic PDA.
Next symbol is and then make the decision. Oh, the next symbol is B,
No.
so I don't.
Because once you move ahead,
Oh, okay.
yeah, unless you push this or something in a stack, you cannot go back in the tape
Okay.
and process that. You cannot do that. But how did we program the non-deterministic finite state automata? DFS, it's a tree search algorithm. You make, okay, how would I program this? Let's say, okay, I start. What's on the tape? AABB. I start. I'm in Q1. What can I do? I can do, let's say, this. I can do this, or I can do this. Okay, so you have two options. You expand the tree. I can do the EE move. Or I can do the, what's that? The AEA move. Well, let's go ahead and do the EE move. I'm in Q2. Right? And I see A on the tape. There is no transition, so this is a dead end. You cannot move. So that was the wrong move. You backtrack, DFS, you backtrack. Well, let's do this move. So you do this move, and you're keeping track what's on the stack, right? The current position in the array or whatever the tape is. Okay. Okay, so you backtrack. If you see an A, you do this move. You push it now. Okay, push it on the stack. Now I'm in Q1. I can again do this move or this move. So I can do, let's put the wrong move first. Or I can do this. Okay? Again, you have two options. Or go ahead and do this. Depth first search. If you do that, then you're in Q2 and you still have an A now. You just push this. What did I do? I pushed it and I'm here and I want to